we need to know some things about quadratics in order to move into our unit on polynomials and rational functions. So let's just review a few things to know about quadratics. First of all, vertex form is a transformation of a quadratic. So think about the fact that if we just had a little equation f of x equals x squared, the vertex would be at the origin, and it would have a certain amount of steepness. You'd go over 1, up 1, over 2, up 4, and so forth. When we add a number inside the function, it shifts the graph, in this case, to the left one, and then this one shifts it down 32. So the new vertex now is at -1, -32. So there's the vertex here of this function. The 2 makes the graph steeper. So instead of going over 1 unit in the x direction and up 1 unit in the y direction, it would go over 1 unit in the x direction and up 2 units in the y direction. And it's just going to become stretched steeper. It's kind of hard to tell with this graph because I had, in order to fit it on the paper, I had to kind of make the x and y scales different. So notice the x scales are going by units of 1, but the y scales are going by units of 2. Normally it would look a little more stretched vertically. Now, in vertex form, we can convert. So I wanted to make a couple notes here that in vertex form, these two numbers here tell us the vertex. So the vertex is -1, -32. And this number here tells us the steepness of the graph. Now we can multiply this out and get this into standard form. So if we multiply this out, it's going to be 2 times x plus 1 times x plus 1 minus 32. So 2 times x squared plus 2x plus 1, if we multiply this out, minus 32. 2x squared plus 4x plus 2 minus 32. So we end up with f of x equals 2x squared plus 4x minus 30, which is what I have down here, and that's called standard form. Now, the vertex form helps us to quickly locate the vertex of the parabola in the line of symmetry, which is at x equals -1. The standard form helps us to quickly locate the y-intercept. So when we see this form, we can quickly see that if we put 0 in for x, we would get -30 for y. So that locates the y-intercept over here. Also, the standard form is very useful for using the quadratic formula to solve and find the solutions. So I went ahead and put the values into the quadratic formula, where a is 2, b is 4, and c is -30. And I went ahead and did some of the simplifying here because I wanted to point out that you always have, this can be split into something plus or minus something, and I wanted to show you what that tells you on the graph. So when I get to this step here, this is -4 over 4 plus or minus 16 over 4, which is -1 plus or minus 4. So the two solutions are x is equal to -1 plus 4, which is 3, or x is equal to -1 minus 4, which is -5. So that's telling, and when I'm talking about solutions, these are the values of x that make y equal to 0. So these tell us that 3, 0 and -5, 0 are x-intercepts on the graph. So you can see up here that here's the 3, 0 and -5, 0. Now, where does the -1 plus or minus 4 show up on the graph? Well, the -1 is the line of symmetry. It is the x value of the vertex, -1. So we see -1 here. And then the plus 4 is how far we go from that center point to this x-intercept. And the minus 4 is how far we go from the center at -1 to the other x-intercept. So the -1 plus or minus 4 gives you the two x-intercepts. Now this part of the graph, this part of the quadratic formula that gives you -1, that's this part right over here, is -b over 2a. So -b over 2a always is the x-intercept of the vertex. So in case you ever see that, that's a quick and easy way to find the x-intercept of the vertex. That's why. It's because of the way the quadratic formula splits down the middle like that. Now, once you've known the x-intercept of the vertex, use the equation to find y. Okay, last one is the intercept or the factored form. So I'm going to recopy this, the 2x squared plus 4x minus 30. So 2x squared plus 4x minus 30. Now to factor this, the first thing I would do is factor out a common factor if possible. So this would give me 2x times the quantity x squared plus 2x minus 15. Then factoring this, the first two terms have to give me x squared. The second two terms have to give me negative 15. And since I want a positive 2x for my middle term, I'm going to have this be plus 5 and minus 3. So this gives me 2x minus 3x, that's the 2x. So if I set this equal to 0, then either x plus 5 has to equal 0, or x minus 3 equals 0. So x equals negative 5, or x equals 3. So when you see the intercept or factored form of the equation, this is a quick way to find the x-intercepts. So let me write this in a legible manner here. So a quick way to find the x-intercepts. And as we talked about on the worksheet yesterday, once you know the x-intercepts, the x-coordinate of the vertex is halfway between the two x-intercepts. So if you see this factored form, you can quickly find the x-intercept or the x-coordinate of the vertex by averaging the two x-intercepts. So in this case it would be negative 5 plus 3 divided by 2, which would be negative 2 over 2, which is negative 1. So there's the x-intercept. Then use the equation with x equals 1, x equals negative 1, to find y. So the y coordinate of the vertex. So this is just basically a summary of the things that we talked about on the worksheet that you did in class together.